Okay, good afternoon, dear students. So we are at the extremely end of this chapter. So it is a very important derivation from point of your examination. It will be asked for 5 marks. Important, right? So here we are going to find out the electric field due to a infinitely long charged conductor. You can take conductor or else you can simply say wire. Both are same. Okay. So here we are going to find out the electric field due to a infinitely long charged wire. If charged wire is there means surrounding that charged wire will find the electric field. Okay, so that electric field at some point, how we need to find out? So about that we are going to discuss now. So here this line AB is the infinitely long charged wire. So here I have taken dotted line for our convenience. Okay, it's not like that. It is a continuous wire. It is a charged conducting wire. So now we have to determine the electric field due to the charges which have been accumulated on the surface of this wire that I have represented here. Plus charges, right? So these are the charges which have been accumulated on the surface of the charged wire. I have indicated in this part only, not in this part. Okay, because but these charges were continuously distributed over all the area of this wire. Now I need to find out an electric field at this point P. P is the point, right? It is at a distance from this charged wire, at a certain distance from the charged wire. At this point P, due to the presence of charges on the surface of the wire, we are going to get an electric field. It will be in this direction. Now I want to find out the electric field at point P. So for that, I will consider a Gaussian cylinder. Already have explained about the Gaussian surface of the Gaussian cylinder. Means it is an imaginary surface. Here we have taken cylinder, means it is an imaginary cylinder which we have considered here in order to find out the electric field. Okay, right. So we will consider that cylinder, Gaussian cylinder, in such a way that the point P should be lying on the third surface of that cylinder. Okay, the point P ಏನಾಯ್ತಲ್ಲ ಇದು ಈ ಸಿಲಿಂಡರ್ ನ ಸರ್ಫೇಸ್ ನಾಲ ಬರಬೇಕು. ಆ ರೀತಿ ಒಳಗ we have imagined a Gaussian cylinder. Okay, so consider an infinitely long charged wire. Infinitely long charged wire A B, right? Imagine a Gaussian cylinder around the wire AB. Let R be the radius of Gaussian cylinder and L is the length of the cylinder. L will be the length of the cylinder. Okay. Now we'll consider Q. Q be the charge enclosed by the Gaussian cylinder. Gaussian cylinder. Q be the charge enclosed by the Gaussian cylinder. And lambda. What is the meaning of lambda? Already we have discussed about the lambda. That is linear charge density. Linear charge density means the number of charges per unit length of this wire. Number of charges per unit length of this wire. So that is linear charge density. Now, in this Gaussian medium, we are going to have the electric field. If there is electric field, means there must be an electric flux. Now we will discuss about the electric flux. So here, the charges were arranged in this manner. Then here I have considered the positive charges. So electric field lines will be exactly perpendicular to the surface of the conductor, means the surface of the wire. That means all the field lines were in this direction, downward direction, because the field line should be perpendicular to the surface of the wire. So here we are not going to get any field lines in this direction. Are you getting this? So we are not going to have any electric field lines in this direction. That means they are not parallel to the surface of the conductor, they are perpendicular to the surface of the conductor. That means we are going to have the electric field lines perpendicular to the curved surface of the Gaussian cylinder. Gaussian cylinder is the cylinder curved surface. So ಇಲ್ಲಿ a curved surface ಗೆ electric field lines perpendicular ಆಗಿರುತ್ತವು. Is it clear? But the electric field lines were not parallel to the axis of the cylinder. So ಈ direction ನಾಗ field lines ಇರುವುದಿಲ್ಲ. Is it clear? So only the field lines will be perpendicular to the curved surface. We don't have any field lines passing out or passing through the end faces of the cylinder. The end face ಏನದವಲ್ಲ ಇದು through ಯಾವುದೇ field lines ಹೊರಗೆ ಬರಂಗಿಲ್ಲ perpendicular ಆಗಿ. Is it clear? Then here we are going to have the electric flux through only the curved surface. Imagine the three-dimensional diagram. Only through the curved surface. We are not going to have any electric flux through the faces of the conductor because we don't have any component of electric field through these end faces. Is it clear? Survey diagram. The electric flux through end faces of cylinder is 0 because there is no component of electric field, right? Okay, then here we have considered point P, which is on the surface of the cylinder at a distance r from the surface of the wire, right? ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೂ ಡಿಸ್ಟೆನ್ಸ್ r ಇರ್ತದೆ. Okay, ಯಾಕೆ ಹೇಳ್ರಿ? Because here the radius of the cylinder is r. So ಇಲ್ಲಿ r into radius ಅಂತಂದ್ರೆ radius of the cylinder. So wire has been placed exactly at the center of the cylinder. Then the distance from the surface of the cylinder to center of the cylinder is r. Let P be a point on surface of Gaussian cylinder at which is at a distance, this is the distance r from the wire, long wire. Now we'll come towards the electric flux through the whole Gaussian cylinder. So electric flux through Gaussian cylinder. So that is pi E. Now simply you can write pi only. Pi, that is electric flux, is equal to electric field into area of Gaussian cylinder. I need to write, but here we are not going to have any electric flux through the end face of the cylinder. Field flux lines irangilla. Okay, so already we have said this point, right? Then flux only through the curved surface. Curved surface na maatra flux irtade. So E into area of curved surface, area of curved surface of Gaussian cylinder. So pi E is equal to E into, what is the formula to find out area of only the curved surface? That is 2 pi r into length L. Okay, so call this as equation number 1. The next, by Gauss law. By Gauss law, we have the total electric flux is equal to 1 by epsilon naught times the total charge enclosed in that surface. So that is 1 by epsilon naught, and what is the total charge enclosed in this Gaussian cylinder? That is, here we have written Q. So Q divided by epsilon naught. But lambda, that is the linear charge density, is equal to charge per unit length. This you have known. The previous classes I have explained about this one, linear charge density. So then this implies Q is equal to lambda into L. L will come this side. Okay. Now substitute this equation in the above one. We'll get, that implies pi E is equal to, instead of Q we need to write lambda into L divided by epsilon naught. So call this as equation number 2. Now equate equation 1 and 2 will get, that is equation 1 and 2 we need to equate. So that implies, so E into 2 pi r into L, which is equal to lambda L divided by epsilon naught. Why have equated equation number 1 and 2? Because at the LHS of equation 1 and 2 we have the electric flux. The same factor we are going to have here, pi. So that's why I have equated these two equations. This is the general form. Okay, this is the specific case for this expression or for this derivation. So then look here, L is going to cut. Then what we are determining here? The electric field, right? The electric field means E as it is. So you have to bring this 2 pi r factor to the RHS side. So that is 1 divided by 2 pi kelagade bantu. Okay, and epsilon naught I am going to write it first. Epsilon naught Then what we are remaining with lambda divided by this r. It's a very important expression. So in vector form, in vector form, electric field E is equal to 1 divided by 2 pi epsilon naught lambda divided by r. So here, if I want to represent it in a vector form, I need to specify its direction. Okay? So in order to give only the direction, I'll take the unit vector n cap. Okay? So where n cap is the unit vector along the direction of electric field. Is it clear? So if you have asked for examination, you have to write till this one. It will carry the 5 marks. Okay?